From there, source standards and vendor guidance to inform each baseline. Internal policy sets direction, but vendor documentation and recognized security frameworks supply the technical details. Using industry resources like CIS benchmarks, DISA STIGs, or vendor hardening guides saves time and lends credibility. Adapt these references to your environment rather than copying them verbatim. For instance, if a vendor recommends disabling an unused service, verify that no business function depends on it before enforcing the change. Sourcing from trusted standards ensures baselines rest on proven practices while still fitting local realities. This balance keeps guidance authoritative yet practical. Parameterize settings with clear rationale for every choice. Each configuration value, password complexity, timeout duration, encryption requirement, should carry an explanation for why it exists and what risk it mitigates. Parameters transform the baseline from a static document into a policy-backed tool. When exceptions arise, the rationale helps evaluate impact. For example, a database timeout value of 15 minutes might reduce exposure to unattended sessions. The record should note that reasoning. Parameterization also enables automation because settings are expressed as variables rather than hard-coded text. Clarity in rationale turns enforcement from mechanical repetition into informed practice. Once defined, enforce baselines through gold images and templates. Gold images create standardized system builds that include approved settings from the start, while configuration templates apply those settings continuously through automation tools like Ansible, Puppet, or cloud policies. Using gold images ensures that every new deployment begins secure by default. Using templates keeps existing systems aligned over time. For instance, spinning up a new virtual machine from a hardened image guarantees that encryption, audit logging, and patching settings appear instantly. Templates and images together convert written baselines into operational reality. Consistency is not a slogan, it's a deployment method. Version control ties baselines to approvals and history. Every change to a baseline should flow through documented review and change management channels. Store configuration scripts and documentation in a version-controlled repository with visible diffs, approvals, and timestamps. This record allows quick rollbacks if a change introduces risk and demonstrates governance to auditors. For example, when a patch requires disabling an obsolete protocol, the commit history shows who approved it, when, and why. Version control brings traceability and accountability, ensuring baselines evolve safely rather than drifting quietly. Controlled change makes secure states sustainable. Drift detection and reconciliation cadence keep baselines alive after deployment. Drift occurs when systems deviate from their approved configuration through manual changes, patches, or operational shortcuts. Regular scans and configuration management tools can detect mismatches between actual and expected states. For instance, if a firewall rule disappears or a service re-enables itself, drift reports flag it immediately. Reconciliation schedules, daily for critical assets, monthly for others, ensure timely correction. Over time, drift rates reveal where governance or automation is weakest. Detecting drift quickly turns silent vulnerability into manageable variance, proving that the baseline still governs reality. Exceptions are inevitable, but they must be tracked with expiration dates and justification. Sometimes a legacy system cannot meet a setting without breaking functionality. In those cases, document the exception, explain the risk, and assign a closure timeline. Automated reminders prevent temporary allowances from becoming permanent bypasses. For example, a storage node awaiting firmware updates might retain weaker encryption for 30 days, with planned remediation logged. Expiring exceptions demonstrate maturity. The program accepts imperfection but refuses stagnation. Transparency in exception handling distinguishes managed risk from unmanaged neglect. Evidence of compliance should include configuration snapshots, file hashes, and baseline manifests. Snapshots capture full system states for reference. Hashes verify that templates remain unaltered. Manifests list the expected components and versions. Together, they allow auditors to validate conformity without recreating environments. For instance, comparing a stored hash of a gold image against a running machine confirms consistency in seconds. Evidence makes compliance measurable, and measurable means repeatable. A good baseline program can prove its integrity at any time through simple, factual data rather than narrative explanation. Proof replaces persuasion. Rollback plans must be tested and rehearsed, not just written. Baselines evolve, and sometimes updates cause unintended instability. A rollback plan ensures the organization can restore prior configurations quickly. Testing these plans reveals hidden dependencies, like scripts that fail under new OS versions. Practicing recovery through sandbox drills or patch test beds builds confidence that reverting will work under pressure. For example, a network team might simulate restoring last week's router configuration after a failed update. Rehearsed recovery transforms fear of change into controlled agility. You can only move forward confidently if you know you can step back safely. Validate provider inheritance and identify gaps when relying on cloud or managed services. Providers often claim compliance with specific baseline controls, but those assurances need verification. Request configuration evidence, review shared responsibility matrices, and confirm that inherited settings align with your internal standards. For example, if a cloud provider handles operating system patching, confirm its frequency and scope match your policy. Gaps like missing logging parameters or unverified encryption standards require compensating controls. Inherited security is still your accountability. Validation ensures that external claims integrate seamlessly with internal baselines. Trust but verify always applies. Sampling across environments and tiers proves coverage. Select representative systems, production, development, cloud, on-premises, network, and verify that baselines apply consistently. Sampling uncovers drift patterns specific to certain layers or business units. For example, development servers might show more deviations due to experimental activity, signaling the need for tighter change controls. Sampling also reassures auditors that compliance is systemic, not isolated to showcase systems. It transforms verification from theoretical assurance into field evidence. Checking a few random doors tells you whether the building is truly locked. Metrics complete the picture by tracking drift rate and closure time. Drift rate measures how often systems diverge from baseline. Closure time measures how quickly they return. Low drift and short closure indicate strong governance. Rising numbers hint at fatigue or automation gaps. For example, a quarterly report showing drift decreased from 10% to 4% demonstrates measurable improvement. Metrics guide resource allocation and keep leadership informed about control health. Numbers turn maintenance into management, giving visibility to what would otherwise remain invisible. In closing, the best baselines are those people actually follow. CM-2 is not about freezing systems in place. It is about defining, enforcing, and sustaining configurations that reflect both security and practicality. When baselines are clear, version-controlled, monitored for drift, and paired with real evidence, they become a living framework rather than a forgotten document. Security teams gain predictability, auditors gain trust, and operations gain stability. Baselines are the quiet rules of order beneath every resilient system. Written once, reviewed often, and lived every day. Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.